Hello, Honors Algebra students. Mr. Lawrence here, and unfortunately I cannot be there with you today. I wanted to be there with you, but my son got sick Monday night, probably about 8:30, and so I'm going to be home with him today. I don't know if I'll have time to grade your test. It depends on how sick he is. If he's cool and just watching TV and chilling, I'll be able to get a lot of schoolwork done. But if not, I'll get to them as soon as possible. Anyway, let's get on with the lesson. We are ready to start Chapter 8. Some of you have kind of already started it, maybe like 5 of you between the two classes. But for the rest of you, we are going to be adding and subtracting polynomials. Now, you may be asking yourself, what is a polynomial? And I want to tell you, contrary to popular opinion, a polynomial is not when you punish your parrot by not giving it dinner. Okay, get it? Polynomial. Ha, ha, ha. Sorry, something in my throat there. Poly means many, and polynomial means many terms. So, for example, you might have an expression that looks like this, where you have 3x squared plus 2x plus 5. That is an example of a polynomial because there are 3 terms put together. There's a constant, a term which does not appear to have a variable. And I say that because there's actually a variable there that you can't see, and I'll explain in a minute. There's an x term, right? And then there's an x squared term. Okay, the number in front, the coefficient, tells us how many there are of the x squared term. So there's 3 x squareds. There's 2 x's, but there's an x term right here. Okay, now that whole thing about the variable being there, there's actually an x to the 0 power sitting here. Yeah, because any non-zero number to the 0 power is 1. So I can think about 5 as 5 times x to the 0 power, or 5 times 1, which is simply said as 5. Okay, so this is an example of a polynomial. Okay, there are different types of polynomials, and we'll talk about them in a minute. And I noticed I used a term when I talked about the 5, I called it a constant because it appears to not have a variable. That falls into the study of polynomials. Technically, it's not really a polynomial because it doesn't have a variable, but it's a constant. All right, so let's see here. Before we start adding or subtracting our polynomials, we have to classify them. And we're going to do this in 2 ways, okay? First, we're going to classify by the number of terms, and then we're going to classify by degrees. Okay, so let's see. If a polynomial is 1 term, like for example, a 1-term polynomial might be like 6x to the 7th. That is a 1-term polynomial. Okay, or 3x to the 4th. That is also a 1-term polynomial. We call those monomials. Yeah, I'm going to get rid of this here. Sorry. Monomials. So, let's see here. Let me spell monomial for you. Monomial. All right, monomial. Mono meaning 1. Okay, now if there's 2 terms involved, for example, like a 2x cubed plus 5. And I know 5 is a constant, but it's okay to have that there. 3x to the 3rd minus 2x squared. There's 2 terms in both of those. Those are called binomials. Binomials, yeah. Let's see here. Make sure I'm not erasing too much. So those are binomials if there's 2 terms there. Now, the president has power to go ahead and pause that video at any time. Okay, binomials. All right. Now, 3 terms might look like this. X squared plus 5x plus 6. Okay, there's a 3-term polynomial. Or it might be, 4x cubed minus 2x squared plus 4x. Okay, there's a 3-term polynomial. And those are called trinomials. Yeah, trinomials. I'm sure you could have guessed that by now. All right, so trinomials. Okay. Then, finally, If it has 4 or more terms, we simply call it a polynomial. A polynomial. Okay? Now, to classify by degree, we look at the highest degree or the highest exponent found. For example, if I have 6x squared plus 3x, that's a binomial, right? Well, the highest exponent is 2, so therefore this polynomial is degree 2. Okay? If I have a, let's say a trinomial of 2x minus 3x to the fourth plus 5x cubed, okay, this would be degree 4, right? This would be degree 4. Okay, if I have a monomial like this, 5x to the second y to the eighth, this is degree 10 because I add up the two, because it's all being multiplied. This is one term. Okay, now you actually know the names of these degrees classifications. I told you degree 2, degree 4, etc. But you know what they are. Degree 1 is linear. Yeah, right, linear. A linear expression like 3x plus 5. Okay, second degree is quadratic. Quadratic. So like 4x squared plus 2x. That's a quadratic binomial. Okay, it doesn't have to be a binomial, but it is. All right, degree 3 is cubic, right? And degree 4 is quartic. Quartic, if it's degree 4. And then after degree 4, we just classify it by the number. Okay, it's degree 5, degree 10, whatever the case may be. All right. So now, well, by the way, you need to memorize those. You should already have the linear, quadratic, cubic, and quartic down. It should be review. So all you have to memorize are monomial, binomial, trinomial, or polynomial. Now, if you are rusty on linear, quadratic, cubic, quartic, maybe make some flashcards, okay? All right. So now we're going to add and subtract polynomials. And this is so simple. All you do is combine like terms. So problem number 1 is addition, right? And I'm going to look. I have 3x to the fifths. In this quantity, I have 5x to the fifths. Well, how many x to the fifths do I have? Well, I think I have 8x to the fifths. Right? Addition is just counting. If I have 2 apples and 3 more apples, I have 5 apples. Not 5 apples squared, right? I just have 5 apples. Well, here I have 3x to the fifth, 5x to the fifth, I have 8x to the fifth. Now I look at this x cubed term, and I notice there's no other x cubed term. So I just bring him down. Plus 4x cubed. All right? And then a minus 2x, because he doesn't have a like term to combine with. There you go. Okay, now I've got to be careful on subtraction because I have a negative in front of the quantity, which means I have to distribute the negative. I'm going to apply the negative to all the terms. So this problem really becomes 6x cubed minus 2x squared plus 5x, and then I can change it to an addition problem and add negative 4x cubed minus 2x squared plus 4x because I distributed the negative. Oops, hold on a second here. So let me move that down a little bit, and I'm going to combine like terms again. That's all I'm going to do. So I've got x cubed terms. Oop, there's some more x cubed terms, aren't there? And then I've got some x squared terms. Notice I'm grabbing the signs with them, and some x squared terms right there. And then I have some x terms. And over here I have some x terms. So I'm just going to combine them together. So it looks like I might have 2 x cubed terms. 6 minus 4 is 2. 2x cubed. I have minus 4x squareds. Because I have negative 2x squared and negative 2x squared. Negative 2 plus negative 2 is negative 4. And then finally, I have a positive 9x because there's 5x and 4x, which makes 9x. All right. Why don't you go ahead and try this one on your own? The president can pause the video, and you can look and see my answer when you're ready. If you're still watching, I'm assuming you've already done the problem and ready to go. I know that I'm going to have 3x squared. Yeah, I'm not showing all the work. Okay, but I've got 7x squared minus 4x squared. Okay, then for x terms, I think I'm going to have minus 16x. Minus 16x. Because I have negative 8x minus 8x. Right? And then I'm going to have plus 10. So, if you got that answer, you go ahead and quit paying attention, and you go ahead and get started on the homework, Excel 8.1. If you didn't get that answer, watch me. Okay, so first thing I'm going to do is distribute the negative. And so I'm going to just rewrite this 7x squared quantity minus 8x plus 3. And then, of course, I distribute the negative to all 3 terms. If there were 7 terms, I would distribute to all 7 of them. So let me close this quantity, put a plus sign, and I'm going to get minus 4x squared minus 8x plus 7. And so I'm going to get 3x squared minus 16x plus 10. And if you still don't see it, I'll get the highlighters out. And I'll do that for you. And then hopefully you can see what's going on. All right. There we go. And I think you'll find that my answer below comes directly from all that work. All right, so that's it for the video, ladies and gentlemen. I would like you to start Excel 8.1 if you haven't done so yet. And if you'd like to work with somebody, that'd be great, as long as the sub says it's okay, and as long as you're on task. Hopefully I'll be back Wednesday. All right, Mr. Lawrence signing off. Have a good night, everybody.